Hey, everybody, this is Mark Smith, the host of Digital Roughnecks, and I'm here with John Kalfayan, who is the VP of Energy at Hivecell. Welcome, John.
Thanks, Mark. Thanks for having me.
So, as you know, Digital Roughnecks covers all things digital transformation when it comes to oil and gas. And, as somebody who's in the energy AI field, I can tell you the intelligent edge is such a key component, which is why I'm super excited to have John here with us as a guest on the show. So, John, tell us a little bit more about your background in oil and gas and why you came to be part of Hivecell.
Yeah, absolutely. I am a degreed mechanical engineer and right out of school went to work in the field as a frac engineer. Did that for a little bit, then moved into the office doing technical and sales support on the hydraulic fracturing side. And then about 5.5 years ago, moved over to a company that was doing surface and downhole data acquisition. And did that for them for about 5 years, and then recently moved over to Hivecell back in January. But the most interesting thing about Hivecell that really drew me to it was this idea of being able to bring your compute, bring your cloud, bring your apps, to the well site. I think there's a tremendous amount of opportunity to be had in the space when you start reframing how you think about where your apps can live and what you can do with those apps when they are localized in the field without having to have the requirement of, say, internet access. The other big, primarily attractive thing for me was this concept of high availability and data redundancy. So as you can see behind me, you can stack up the Hivecell nodes, and then anything that's running on any of those nodes individually, if one of them were to fail, fails over to any of the other available nodes that you see within the stack. So you have this backup, redundancy, peace of mind, insurance, whatever you want to call it, which, as we all know in the oil field, is time is money. So if you can prevent downtime or NPT, or not have to hotshot a new part out or find a flight to send the technician out on the next available flight, there's a tremendous amount of savings and efficiency to be had there.
I remember our first pilot we did with an oil and gas site. And so we've got our cameras all set up, and we got this bill from Verizon for $14,000. And we said, holy crap. Okay, we can't do that anymore. We got to have an edge device, right? We got to be processing this thing on the edge and then only send up the exceptions or results up to the cloud, or we're going to burn through bandwidth and stuff. So tell me about some of the problems that Hivecell solves.
Absolutely. Yeah, there's a couple different pain points here. One, as you just mentioned, is just the sheer volume of data, right? So just looking at some recent stats, the volume of data over the last decade grew 50-fold in the digital universe, to the point that they actually had to create a new unit of measure called a Bronto byte, which is 10 to the 27th for all those that are interested. But volume is a big component, and it's estimated that 75% of the new data created over the next 5 years will actually be created outside of the traditional cloud. And so that if it's being created outside the cloud, you obviously need somewhere for that data to go, which is the edge. And as you mentioned, not all of that data needs to be pushed to the edge. The cloud has kind of become this giant repository for our data, but just pushing the data to the cloud doesn't magically make it useful or more or valuable or easier to use or consume. And so that's one of the big ones, being able to bring that storage and compute locally to the data, in instances where you have this concept of, by exception, where you ingest all of the data that you have, it runs through its processes, applications, compute, and then the thing that's valuable is the output of that process. Well, that valuable thing can then go to the cloud, but you don't need to push all of that data up to the cloud just to get to that valuable piece. The other component of it is, offline and connectivity. Being able to have things like air gap processes where there's literally no internet connection, but you need something to run and be computed. in real time, or have automations or control systems that are being controlled in an air-gapped or disconnected environment, or even just environments like the oil field where you may have connectivity some days, you might not the others, but you can't stop operations because you don't have connectivity. And so being able to have a computer or servers locally that are sitting there constantly running, whether there's connectivity or not. If there is connectivity, your data gets pushed up to the cloud, or the important data gets pushed up to the cloud. If there isn't, it keeps on running and you keep on moving down the road. So your operations and processes aren't stopped.
So what's different about, Hivecell compared to just a regular small PC that you might put out there?
Yeah, for sure. So a couple of our big differentiators, for one, as you can see behind me, they're modular. So you use the term Legos, and I'm a big Lego fan. So that's exactly what they are. Or that's how you can think about them. You can literally stack them up and scale them as you need. So our business model is built around individual nodes. So if you have 3 nodes in a group or a stack like this behind me, we call that a cluster. And that cluster allows you to do some very, very interesting things, like having high availability and data redundancy. So as I mentioned, I can literally come in here and turn one of these off, and the processes on that node, and the data off that node are distributed across the stack there. So your processes and data aren't lost, or they don't quit running just because one of them fails or dies. We've also got built-in battery backup, as you can see. So I can literally take this off the stack and it's still running. All the processes and everything are still running there. And they have a Wi-Fi communication with each other when you do disconnect them physically, so that everything keeps on moving and keeps on running down the road. Another big benefit that we offer is this concept of scalability. So a lot of edge applications, you have to kind of try and game plan or think out, how much compute resources I'm going to need, not just today, but also in the future for additional processes and applications that I might be running, which it's hard to estimate what those may be, or how much storage or compute you may need in the future. And so instead of having to overbuy what you might need in the future, or overcommit to something that is theoretical in the future, we allow you to buy what you need today. And then if you need more in the future, you literally just add another node to the stack and keep on running. Additionally, our design was made to be as simple as possible. So you have a power cable and an Ethernet cable, and that is it. There's no need for having any kind of networking engineer, networking technician, software engineer, or anything like that to go out on site like you would have with traditional kind of edge deployments.
So it scales horizontally. And so, yeah, if you run out of compute power on one node, you add another node, it just starts scaling horizontally, and it offers failover. So, and the business model is like hardware as a service, right?
Right. So that's kind of the other big differentiator on our end, is everything that we do is as a service. So just like your cloud providers are currently offering you their services as a service, so do we. And what that means is you're not buying the hardware, you're buying the turnkey solution as a service. So that includes the hardware, the framework licenses and runtime licenses. So that would be Kubernetes, Kafka, or HCI and VMs. So those licenses are also included. And then if the hardware itself dies or fails for any reason, we automatically replace that as part of your cost. And if you're under a long-term contract, we'll even upgrade the hardware every 3 years. So the whole goal behind our business model is everyone is used to the cloud, where it's just hands off and you're focused on the application and the apps themselves. You're not worried about managing hardware, replacing hardware, updating or upgrading hardware, or anything like that.
Great. So John, how would people find out more about your product?
Absolutely. To find out more about us, I've got a special landing page set up. Those will be in the link on the show notes.
John, I want to thank you for being a guest on Digital Roughneck, and I'm really excited about your product and what you bring to the oil and gas operations.
Absolutely. I appreciate